Okay, to start solving this problem, we need to use energy. Because we're not told the shape of the slope. It might look like this. It might look like, it might be a straight slope. It might look like this. All we're told is that there's no friction. We don't lose energy. So, let's look at how to do this. Well, we know that our change in gravitational potential energy is equal to m times g times delta h. Now, we are not given a mass, and we'll have to factor that in at the end. But we'll leave it as m for now. And remember that here g is equal to 10. We're allowed to assume that. And delta h is negative 500 meters, which is quite large. So we lose 5,000 times m joules, where m is the mass. Okay, so that means that our change in kinetic energy, and therefore our total kinetic energy, because we started stationary, has to be equal to 5,000 m joules. Because since that UG isn't dissipating any other way, it has to go into kinetic energy. So remember that kinetic energy is 1/2 mv squared. Since it's a cube, it's not rolling, so we don't need to worry about rotational. We just have linear. So now we can simplify. We can divide out a 1/2 m, and we get that 10,000 equals v squared. Okay, so then v equals 100. Okay, so now we've determined the final velocity, and this is important. Now we'll look at momentum to solve for the impact force. So we know that the momentum is equal to 100m. Remember, P equals mv, and therefore P for this is 100m, because the velocity is 100 and we don't know the mass. So that's the P initial, the P before the collision. The P after is the P final. The final momentum is 0. Because it stopped, right? You can't have momentum if you're not moving. So our delta P is negative 100 meters. Okay, so here we go into, remember that delta P over delta T is equal to the force, right? So then all that remains is to take negative 100 m over 0.01 seconds, and we get a force, and I'll simplify to the magnitude of the force here. The direction matters, but we're just going to care about the magnitude. 10,000 m newtons. So for every kilogram that the object has, that the cube has, there's going to be 10,000 newtons of force. So if it weighs 1,000 kilograms, it's going to be 10 million newtons of force.